Okay, let's go ahead and work our way through the next bit and see how we do. All right, how many moles of magnesium are in 3.01 times 10 to the 22nd atoms of magnesium? Okay, so I need to know, since I'm starting here, right, this is the value I'm given, 3.01 times 10 to the 22nd atoms of magnesium. That's what I'm starting with. I want moles, and I know that in 1 mole is 6.02 times 10 to the 23rd particles, right? So that's what I'm going to use in the next step here, right? I want atoms to cancel. Atoms is my particle, so that's what's going to go here. 6.02 times 10 to the 23rd atoms in 1 mole of magnesium. All right, I plug that in my calculator here. Let's clear this off. I have 3.01 times 10 to the 22nd times 1 divided by 6.02 times 10 to the 23rd, and I get 0.05 moles of magnesium. Okay? Now, next one, I have 4 moles of glucose. I want to know how many atoms there are. Okay? But first I have to get from moles of glucose to molecules of glucose, because this is a molecule, and then I can go from molecule to atoms. So I'm going to again start with what I'm given here. 4 moles of C6H12O6 times, right, 1 mole of C6H12O6 contains 6.02 times 10 to the 23rd molecules of C6H12O6. Okay? But each molecule contains 6 plus 12 is 18, plus 6 more is 24, right? There are 24 atoms for each molecule, right? So I'm going to have 2 factors I have to put together here. So 4 times 6.02 times 10 to the 23rd times 24. Notice I left out the dividing by 1 on each of these because dividing by 1 won't change anything. And so then here I get my answer. Here I'm going to have 5.78 times 10 to the 25th atoms in all of that. So that's my answer there for that. Okay. Now, in this one, I have 28 grams of CO2, and I want to know how many moles there are. So since I have a mass and a mole, mass and mole makes molar mass, so I'm going to have to know what carbon dioxide weighs first. So carbon is 12.01, oxygen is 16. All right, so I have to add all that up. All right, that's going to be 1, 0, 6 and 6 is 12, 13, 14, carry the 1, 1, 2, 3, 4, 44.01 grams per mole. Okay, so I'm going to again start off with my 28 grams of CO2, but now I can make use of the fact that there's 44.01 grams per, this line means per right here, per 1 mole of CO2, right? Moles is what I'm looking for, so I can stop there. Right, 28 times 1 divided by 44.01. 0.636 moles of CO2. Okay, how many moles are in 452 grams of argon? Right, 452 grams of argon, and I'm going to do the same thing. I've got moles here, just like I had grams and I went to moles. I have grams, I'm going to moles, right? I need the molar mass of argon. 1 mole of argon for my periodic table. Argon is here, 39.95. Okay, 39.95 grams. Okay, so let's do the math. 452 times 1 divided by 39.95 equals 11.31 moles of argon. Okay. All right. This one, I'm going from molecules of F2, right? And I want to know what the mass is. So I have to get from molecules. To get from molecules to mass, I need to go through moles. So 2 times 10 to the 23rd molecules of F2, right? 1 mole of F2 contains 6.02 times 10 to the 23rd molecules, right? So my molecules cancel out there. And then to find the mass, I'm going to need the molar mass, right? Fluorine from my periodic table is 19, right? So 19 times 2 is 38 grams per mole. So this is 38 grams per 1 mole. So my mole cancels out of F2. And I can plug that in my calculator. So 2 times 10 to the 23rd divided by 6.02. Let's get this in right. Second, E, 6.02 times 10 to the 23rd. There we go. Times 38. All right, so here I have 12.6, what do we have, grams of F2. Okay. Now, how many atoms are in 16 grams of silver nitrate? Well, I have to go from grams to moles first, and then from moles to atoms. So we'll start there. 16 grams of AgNO3. How much does AgNO3 weigh? Let's find out. Okay. Silver is here, 107.9. 107.9 plus nitrogen is 14.01 plus oxygen is 16 times 3. All right, so I'm going to add all those up to get the total. All right, 107.9 plus 14.01 plus 16 times 3. And I get a total of 169.91 grams per mole. All right, so that's what it's going to go here. I have grams. I want grams to cancel here. 169.91 grams. This is grams per 1 mole. All right. For 1 mole of AgNO3. All right, I want to know atoms. So I've gone from grams to moles. 1 mole of AgNO3 is 6.02 times 10 to the 23rd formula units. All right, I use formula units because silver nitrate is an ionic compound. And there's 1, 2, 3, 4, 5. So there are 5 atoms for every 1 formula unit. All right, equals. All right, so let's plug this in. 16 divided by 169.91 times 6.02 times 10 to the 23rd times 5 equals. So my answer here is 2.83 times 10 to the 23rd atoms, right? So that's my answer there. All right, let's take a look at these last two here. Which formula has the simplest whole number ratio of elements? That's your empirical formula. Which formula has the actual number? That's your molecular formula. All right, we're going to pause there and then pick this up on the next one.